Hello everyone, I am Soumyasree Senapatai, Assistant Professor of Civil Engineering of Vedang Institute of Technology. Today we will discuss, we discussed about elastic constants and relationship between them. Today we will solve one numerical about those using those elastic constants. Okay. So, before solving this numerical, we need to understand this, what values are given and how we will use those values. Okay. So, first here we have a bar of what? 25 mm diameter. Okay. So, we need to make that bar and given diameter is about 25 mm. Okay. Next is tested in tension. Here given that the bar is in tension, that means load will be in positive. Okay. Here 25 mm is your diameter. We can write here given data D equals to what? 25 mm. Next, it is observed that when load is 60 kilonewton, so applied load is 60 kilonewton. Here P equals to 60 kilonewton load. Okay. Next, here is applied the extension measure over a gauge length of 200 mm. So, gauge length is described here is 200 mm. Okay. Here one word left is extension. What extension? When tensile load is applied, so what will occur? This length will extend. Okay. Before in solving about those Poisson's ratio, we have known that when one load is applied, so bar will extend in one direction and compressed in another direction. So, here extension given is what? 12 mm. We can write here del L equals to 200, L equals to 200 mm and del L equals to 12 mm. Okay. Before we know that if one side elongates, another side will compressed. So, like here contraction is given, contraction in diameter. Okay. Here D equals to 25 mm and del D equals to 0.0045 mm. This contraction and extension will depend on what? The amount of force applied. Okay. So, here we got all the given values and from these values we will calculate all these elastic constants. Okay. Next, to calculate what? Calculation of Poisson's ratio. We know that Poisson's ratio is denoted by what? Mu. Okay. So, mu equals to lateral strain upon longitudinal strain. So, in case here lateral strain will be what? Our del D upon D. Okay. Del D value is given here and D value is given. Okay. So, lateral strain value will be del D is how much? 0.0045 and D is 25, all are in mm. Okay. Okay. From here we can know that strain is always unitless. Why? Because here del D is in mm, D is in mm. Okay. So, in future it will cut and strain is always unitless. Longitudinal strain. How to calculate longitudinal strain? Formula is WL upon L. WL, sorry, it is del L upon L. Del L value is here 12 mm upon 200 mm. We got lateral strain and longitudinal strain. So, we can calculate mu here. Okay. So, okay, you all need scientific calculator to calculate this, as I have calculated before. So, I will write it down. Okay. 0.3 is the value. You can recheck it by using scientific calculator. After calculating mu, we need to go to Young's modulus or modulus of elasticity. Okay. Symbol is capital E. Symbol, if we have written small e, then it will be your what? Strain. Okay. So, how to calculate Young's modulus? Already we have known the formula. What? Normal stress upon normal strain. Okay. So, normal strain is denoted by small e and normal stress is denoted by sigma. How to find out this and this? Okay. So, we can use here, we know that stress equal to P upon A and strain equals to del L upon L. So, E equals to, we can write PL into PL divided by A into what? Del L. Okay. Now, we need to put those values. Okay. So, what is P? The value of P is 60 kilonewton. 60. and L is 200. So, how to calculate the area? How to calculate the area? So, as we know here diameter is given, okay. So, pi by 4 into 25 square, we can easily calculate. Del L is del L value is what? 12. So, the answer will become how much? 203.7 kilonewton per mm square. Okay. Here L, unit of L is in mm, unit of P is in kilonewton. Okay. Likewise, area in mm square. Okay. Del L in mm. So, the unit, how to know the units? Okay. So, unit will become how much? Kilonewton into mm square into mm. Okay. So, here mm will cancel out. We do not need to remember that kilonewton per mm square will happen. Okay. We will calculate in this way. So, we have E and mu value. Yes. Before before the video, in this video we have got the relation between E, mu, G and K. So, from that we know the value, to calculate the value by using E and mu. So, we can calculate G and K by using the E value. Okay. So, to remember what is G? What is G? What is G? G is your modulus of rigidity. Okay. Also, it is called as what? Shear modulus. Okay. So, to remember G, we have got the formula for G is what? Shear stress upon shear stress upon shear strain. Okay. Shear stress is your what? Tau, and shear strain is your what? Phi. So, if in case of you, if you have tau and phi, directly you can calculate G. Okay. But in our question, you can see here. Okay. Here tau and phi are not given. So, we need to calculate from what? From E, that is your Young's modulus. If tau and phi is given, you can easily calculate that G. Okay. So, your G will be how much? We know that E equals to 2G 1 plus mu. Okay. So, G will be E upon 1 plus mu. Okay. By putting the value of E and mu, we can easily get the value. Here E is your 203.7. and 2 into 1 plus 0.3. Okay. So, your value will be 78.37 kilonewton per mm square. You can recheck the value by using the calculator, but formula is this. You need to remember this formula. Okay. Now, next, calculation of your what? Last elastic modulus, that is bulk modulus. Denoted by K. Okay. So, okay. Formula for K is what? We know that normal stress upon volumetric strain is your bulk modulus. But we know that normal stress is given, but volumetric strain is not given. We can calculate volumetric strain, but here in bulk modulus we will calculate in two way. Okay, by using volumetric strain and what? And by using that E value. Okay, first we will calculate using E value. Okay. So, first in case of what? We know that K is your what? Sorry, E equals to 3K 1 minus 2 mu. So, K will be your E upon 3 into 1 minus 2 mu. Now, by putting the value what? E and mu, we can get the result. Okay. K will be how much? 203.7 upon 3 into 1 minus 2 into 0.3. That will be, so it is equals to 160.8 kilonewton per mm square. Okay. We got this value, and if we calculate the volumetric strain, okay, if we calculate the what? Volumetric strain. Okay. So, volume is your what? L into B into H, this much only. In your bar, volumetric strain will become what? That will be your x axis value, y axis and z axis. So, we know that strain equals to del L upon L. Yes, del L upon L. So, in x axis we have del L upon L. Okay. Into, so in y axis this value d and del d upon what? D, and in z axis also the same value del d upon d. Okay. It is del L upon L we have calculated before. Here how much? (12 upon 200 into 0.0045 I think. upon 25 and 0.0045 upon 25. We can write it 12 upon 200 into that is your. So, 0.0045 sorry okay it is okay square. So, EV will become 0.0042. So, this value if we divide it to calculate K, we need what? Stress and EV. So, stress will be your P upon A divided by 0.0042. We can cross check this value by calculating that. Okay. This. So, by using these formulas, we have calculated what? First calculated mu, then E and G and K. Okay. This whole process, the definition, relation and one formula will become your 16 mark question. But in case of if only E and mu is given and we need to G and K, this will be your short type of questions. Okay. Thank you.